Yes, now I'll hand over to Zdenek, who is from Max 4, and I know very well as well. Over to you, Zdenek.
So I will try. Thanks. I hope you can see my screen and
yes, we can see everything. Hear you. I don't see the counter, but that must be my fault.
Okay. So I am from Max 4 laboratory, also from a synchrotron, working there as a scientific software coordinator. And I signed for this meeting very late. So I just will mention a small issue that we hit it with parallel HDF5 and compression filters, as they are like compression filters are popular now. So ingredients is parallel HDF5 and image-like synchrotron data and compression. So people from synchrotrons are not usually speaking much about parallel HDF5. They use more like serial, and they use other types of parallel computing standards as GPUs. We could see, because this standard is about 30 years old and it's very popular in HPC environments. We did a survey within one of the European Open Science Cloud projects, and Sophie Servan concluded from there. She wrote the survey, and 9 from 10 and facilities have Slum clusters, and they have likely other resource managers, so they can run like MPI. Yeah, MPI is an old traditional standard, so it usually requires only 1.8 library for reading if you write data with that. So it's simple and it's very popular in HPC. It is sometimes complicated to install, but the HPC clusters usually have it. There is really even a synchrotron software using parallel HDF5. It's called the most popular is like the one that is using it most extensively is called Savu, which is using parallel HDF5 to exchange data between different stages of the data processing pipeline. Yeah, alternatives we could see it is today virtual datasets, direct chunk write, compression in memory or in GPU. Yeah. Disadvantages, for example, like 1.10 is required, doesn't work with some software. I am focusing, there are like complex synchrotron data and simple synchrotron data. The simple ones are usually image-like data that looks like in this picture. And I'm focusing on them and just give a scale to this problem. We hit it into this problem when we discussed with our collaborators from PSI, a Jungfrau detector that would be producing 16 gigabytes of data per second with compression ratio about 4. So this means about 4 gigabytes per second compressed data. I hit this problem many years ago when I was testing a GPFS storage for Max 4 synchrotron laboratory. I'm aware of many benchmarking tools, including H5 performance parallel, IOR with HDF5 option, and there are many snippets and GIFs on internet because sometimes you don't understand what the benchmarking tool is doing. So the easiest thing is to just write something extremely simple. To just demonstrate that things are extremely simple, I'm showing this piece of code based on H5 and the green cycle is the code that you need to save the image-like data in parallel. Yeah, the shadow part is just a small complaint thing. Like in H5 they have a default filling property that is causing with large data sets larger than 4 gigabytes that the MPI application is crashing. Yeah, but you can work around it very easily by the shadow cycle. To just see how it works without compression, you have to have some reference. Does not matter if I do it with IOR, with my Fortran tool reference one that I based on the code from Timothy that I found on Slack. On Slack on internet. And if I do it with H5 parallel, or if I do it with serial gasket, I have a read-write speed about 5 gigabytes that matches my interconnect to the storage, which is like the FDR. If I have 2 interconnects, I have higher read-writes, uncompressed ones, so it works very nicely. I like it. Parallel HDF5 is great. Here is the last slide, how it works with the compression. If I add the compression that was very popular in the previous presentations and use it on the same data rates, on the same type of data with compression rate 8, also mentioned in one of the presentations. In a read, I am getting about 24 gigabytes. In write, I am getting 5 gigabytes. Yeah. I'm quite happy with the read speed. But I'm quite disappointed with the write speed. Yeah, in compressed, this means in compressed data, it is about 0.6 gigabytes. So the storage is not a bottleneck. I am from the experience, and from the numbers that were shown on the previous presentation, like this system should be able to compress much more the data on CPU in memory, at least 2 times, which was like something that I was expecting and also I wanted. Yeah. And I am also convinced that the people writing in multiple files with virtual data sets in memory compression, even on CPU, not on GPU, yeah, and with direct chunk write can do more. Yeah. So my conclusion was that I like HDF5 parallel, but writing data in a simple way with compression filters is not so shiny on them. So I am either doing something wrong, or I think that there is a lot of space for improvements. So not maybe a lot, but some. Yeah. Thanks.
Okay. Thank you, Zdenek.
A lot. So we are aware of this problem, and we are looking into how we can tune one thing. And we, for example, know that there is a problem when we're trying to scale to 20,000 ranks. So we're looking into it. One thing to remember that you have to decrease communications between ranks and try to write chunks that belong to one process, to one rank. But we need to look into different we need to profile to find out, and it is on our radar. We're very well aware of the problem.
Thank you very much, because this is why I wanted to show that there is a reference with no compression, and I am not doing this hopefully mistake with the big communication. Yeah. And I was reading about HDF5 driver and so on, and what are your ideas how to overlap calculation with IO. And I think that this is exciting thing, and there are even people like me that would use it.
Okay. Thank you very much. And yeah, maybe there will be some comments, some discussion on this.
Just imagine that you would have this 10 gigabyte read speed, coupled with the GPU decompression from the previous speaker. What would be the the rate on which we could analyze data on GPU?
Well, we need this for the Jungfrau too, I think.
It would be exciting to have even something like HDF, this direct chunk write read, and parallel HDF5. This is also like.
Once again on our list.
Not
Okay.
sure what are the technical complications. Thanks.